Hello everyone, thank you for joining us today on this webinar for cracking in render. My name's Jerry, I'm the technical consultant here at SAS Europe, and it's my job to run through any technical issues that people may be having or go to site and assist on site with any technical issues. So we'll talk a little bit about cracking in render. Introduction to the company. We were founded in the 1970s as Specifiers Advisory Service, where we would conduct consultancy services for the NHBC, which we still undertake, and other manufacturers. The company ethos has always been based around technical support, product quality, and innovation. As a company, we strive to hone in on customer satisfaction, be it whatever products that are purchased through us, be it small quantities, large quantities, we always find the time to hone in on the customer and ensure that they are happy. Today, SAS continues to provide technical consultation service to organisations such as the NHBC, and a few of those jobs you will see today in this presentation. We're based in Devon. SAS now manufacture and supply a complete range of products and systems in the UK. So we are a one-stop shop for all render systems and products. The company is accredited with ISO 9001 and ISO 14001 quality management systems, and we hold BBA certificates for various systems and products. Maintain and improve installers training scheme that cater for projects large and small across the whole of the UK. So we run a training course for applicators to come through, learn how to apply the system, and then subsequently, if we're specified on a project or we have a render project, we will then put those applicators onto the project. There's 5 core brands. The Pro Wall system, which is a vented range screen rendered carrier system. ProRend EIFS, which is an external wall insulation system. ProRend, all the base coats and the top coats. ProMesh, which we'll talk about today, reinforced glass fibre mesh. And Bead. The beads been on the market for a long time, very high quality. That's where the business starts from. So, what's on the agenda today? We'll talk a bit about expansion beads, bed joint reinforcement, weak points in the structure, dissimilar material or differential movement as it's commonly known as, hydration cracking, accounting for movement in timber frame, which is very important, preventative measures, and we'll talk about a case study at the end. What I will stop at this point and say if there's any questions that you want to ask, there's a question box on your screens. Also, I will be able to answer any questions at the end. Subsequently, you could also email me. I'll give you all my contact information, and we can send a copy of this to yourselves as well. So we talk about expansion in render. So see, this is a through wall detail, looking down on the wall. So this is effectively showing our Cottages uniform system onto masonry. As you can see, the expansion bead is placed central. Behind the usually behind an external masonry skin, you'll see a bit of concrete band and an expansion bead. This is our expansion bead. These are 3 meters in length, and they're specifically designed to take up lateral movement in an external masonry skin. Very important as well. Mesh is situated in the render, and the placement of these expansion beads is extremely important, and we'll talk a little bit about that later on in this webinar. So it allows for movement in elevations with large surface areas. Expansion beads in the render should mirror movement joints present in the substrate. Now there is some wiggle room on that. It's not just where the expansion is in the substrate, but the expansion bead can be used just to break the render, and I do get asked that question quite a lot, where there might be a large panel and it'd be easier to break it up as opposed to do it at once because the render might be going off. It might be too much of a large area for the subcontractors to apply the render without it curing too quickly. So it can be used as that, or a detail break. Failure of the substrate is the most common cause of cracking in the render, and in my experience, I've been working with the company for 7 years. I've seen a lot of cracks in rendered substrates, and nearly 99% of the time I do find that it's cracking within the substrate that's emanated through onto the face of the render. This detail can also be achieved with 2 stop beads and a silicone sealant to prevent the water ingress. So, for example, if in this detail, say if I had a masonry substrate on one part, and a timber frame substrate with a board system, or they were situated back from one another, you can increase the thickness or decrease the thickness with stop beads and render in order for the stop beads to marry up, which is a good way of ensuring there's a flat surface. In some cases, an expansion bead just may not work, so back-to-back stop beads can work just as well. Placed over a movement joint present in a substrate to reduce cracking, of course. Use where 2 substrates join to eliminate cracking from differential movement, and we'll discuss differential movement a little bit further on. Useful for achieving clean breaks in coloured renders. Okay, now this is a picture of our expansion bead. You can see on the bead itself there's a locking point where the render can lock in underneath, and also it's keyed on the sides in order for it to really key into the render and prevent for any spalling to happen. For example, if you use a monocouche render, there's a nail flow that you use in order to finish it. If you use an expansion bead or a bead which is galvanized, for example, it's liable to rust and also spall once you scrape it back. Ours are 100% UPVC and they're also non-flammable. So, for dense concrete block, it's recommended that the expansion bead is placed every 7.5 to 9 metres according to the NHBC standard. Now, that's not set in stone. There are obviously different blocks types and different block manufacturers that produce the blocks. Always worth checking with the block manufacturer for expansion bead placement. They'll be able to give you the specification on the blocks. So it's not always what's said in the NHBC standard that's correct. You know, there's different densities of blocks. Obviously Brits as well, and obviously that can decrease and increase the expansion placements. Expect to see expansion bead where a wall's change in height, and that is the big one, as regardless of what specification of the block. As you can see in this photo, this wall is about 15 metres long. There was a crack that was situated further along because they didn't introduce a vertical expansion, and also as you can see here in this particular photo, where this parapet wall detail ends and the wall increases in height, there's obviously a crack that runs down there like that. So this is where the expansion bead should have been situated. This would have saved this particular wall. And also further along, this was a 7.7 Newton concrete block. So again, roughly about 6.5 to 9 metres. There should have been another expansion, but there wasn't. The way I always check on site if it's cracked, not only in the render but in the substrate, is I use a feeler gauge, one of my best tools in order to check cracking. So, movement in masonry cavity walls can be caused by a combination of actions including expansion, contraction and volume changes resulting from the effects of moisture within the masonry units, and that's a very common one I see. When it comes to blockwork, it's a porous material. It will take on water content, and that can take on water content when they're stacked on site and if they're not covered, and also once they're laid into the masonry skin under inclement weather. They will absorb moisture. Now, if those moisture levels if there's 12% moisture content by volume of the block, it must be released prior to rendering. Now the reason for that is that if you render over a saturated block, once the moisture content releases through the render as well, the blocks will actually decrease in size, and that's called shrinkage. So the shrinkage cracks is what I do commonly see on rendered elevations. Temperature variations, of course, mostly you always find that on a southern facing wall or a wall that gets the most sun, that there's this higher thermal movement at play, because there's much more heat acting on that surface. So under cooling, it decreases in size and it increases in size once it's heated up. So that's a lot of thermal movement. The size and shape of the masonry panels, as well as the distribution of openings and restraints, is of course the more openings that you've got, the more chance of cracking. You know, it's decreasing the strength of the overall elevation. Movement joints will probably be constructed to cater and calculate a degree of movement. Now, this is generally undertaken by a structural engineer in the design process. Let's go back to that slide. So, thermal movement and the forces directionally proportionate on the length of wall. So this is as you can see, just say for example a gable end of a property. There's no expansion in this first detail. So the thermal movement acts on the wall in the way of actually pushing the external corners out. Okay, if there's no expansion bead central, there's going to be a high chance you're going to get cracking on these corners. Okay, an introduction of a expansion bead central will reduce the risk of cracking on the external corners, but it will not stop it. Inserting an expansion bead within a metre of the corner is the best way of setting out expansion beads. Now, if this length of wall is quite long, say that was 12 metres for example, then we would recommend an expansion bead central. So that prevents any of the external corners cracking, and also prevents cracking central to the wall. So, natural movement forces on a proportionate to the length of wall. This is the external leaf, as you can see, this is an internal corner. So you've got forces acting on the wall this way and that way. And as you can tell from the drawing, you're likely to get a crack here and crack here if you do not insert an expansion bead detail. Inserting an expansion bead here with an incompressible joint behind, again, is better. But acting on this way, if it breaches that compressible joint and expansion detail, there's still a possibility of a crack there. So the best way in this arrangement, or the best way to actually put the expansion bead in there would be at this point here. So the external masonry skin can move in and out of one another without cracking the external render. Bed joint reinforcement. Bed joint reinforcement should be provided in the first two courses of the external masonry leaf, above and below any openings, window apertures, doors. Where possible, reinforcement should project 600 mm past the opening. Now this is a very important one, and I do see this a lot when I'm going to site if there is cracks around the render, because this is the areas where it would be. Inserting bed joint reinforcement here and here in two courses above and below is an absolute necessity. Now, this is the areas where you're going to receive the most cracking, because there's a lot of people, you know, when people are living in these properties, are opening and shutting the windows, slamming the doors. So this is where you're going to find your cracking. So this is paramount that this is put in. Bed joint reinforcement, not only just around the windows, but in the external skin of the masonry wall, can also increase your expansion bead placement. So if you put it in every joint, a mortar joint, bed joint, one courses or every two courses, it will increase the strength of the wall, and then furthermore increase your expansion placement. Again, that would be down to the structural engineer to assess. Incorrect jointing in blockwork around the aperture. As you can see, this is a photo I've taken on site. So this is the window sill, and you can see that straight joint running right the way down there, and there's a straight joint there. Now, but even prior to any rendering to that, you can see that is cracked. So if I put a render onto that, it will emanate through the render. There's no two ways about it. So this had to be taken out and relaid in order for it to comply with this jointing. So there should be a block central to the window, and this reveal line should not fall in line with the joint underneath it. And everything should be bonded correctly. So 1/2 in the middle, 2 3/4, another 1/2 and 2 3/4. That's the best way of doing it. That prevents any cracking in around windows. Weak points in the render system, of course, sill to head, this is where you'll see it. Lintel to lintel, you do get a lot of thermal movement with the lintels as well. You do see cracking from there to there. You see cracking spurring off from the doors. And a lot of the time it's because of no bed joint reinforcement. But with regards to the render, our specification would be to fully mesh the elevation in glass fibre reinforcement mesh, and additionally 300 by 300 minimum patches on all 4 corners. Then that prevents any cracking that can occur within the render, providing that the masonry substrate has been constructed correctly. You may also see cracking on the external corners if you don't insert an expansion bead on the external corners, and potentially one central as well. But when inserting expansion beads, it's imperative not to put it over or through any apertures. It must be situated away from the apertures and not be broken. Very important. So this is a common, detail of what our mesh would be in the substrate. So as you can see, mesh is all running that way. It doesn't matter with mesh, it doesn't matter if it goes vertically or horizontally. The key is to make sure that the mesh is overlapped. And usually what you find on glass fibre reinforcement mesh is there's a 100 mm overlap line. Now if you fail to do the overlap and you leave the mesh just adjacent to one another, then under the curing it can actually split the render as well, because it's pulling on the render in 2 different directions. So the overlap is very important. Must be made sure that it's overlapped. So specifying mesh in render. So what are the considerations? The cheaper mesh can be pulled apart. So this is our grade 5 mesh, for example. This is the one that we would put in our Cottages system or any render system on a masonry substrate. As you can see with this mesh, it's physically impossible to break that apart. Now, with cheaper meshes on the market, you will find that you can pull apart those apertures in the mesh, which really highlights the fact that it's a cheaper mesh. It's woven glass fibre strands, pressed, weaved, and this is the big one, alkaline resistant. Now, if a cheap mesh that you might get on eBay, for example, from China, it's very unlikely to have an alkaline resistant coating. Now, cement contains alkaline. It's the alkaline that actually breaks down the mesh. So if you use a cheap mesh in the render, which is high in cement content, it's likely that it will break down and cause the cracking issues further down the line. It might be quick, or it might be a year later. Very difficult to tell, but it will crack it eventually. So using a strong alkaline resistant mesh is what you would need. And below here, you will see that this is our E-tag testing that we've done on our mesh. And they laid the mesh in an alkaline solution, like a bath. And you can see from the tensile strength in the original condition, the warp and weft strength is 51 and 55 newtons per centimetre. Now, the tensile strength after the alkaline treatment for 24 hours, it only dropped by about 39 warp and 45 weft, which is still very good. And the tensile strength after the alkaline treatment, after 28 days, so it's been sat in there for a very long time, only went down to 35 to 37. So it just sort of highlights the quality of the mesh that we actually put into our render systems. So the mesh tear strength is measurable and should be available from each manufacturer, of course, and you will find it in the MBS clause M20. Mesh placement is also incredibly important. So we look at these two examples here. Now this is a thermalite block, and you can see that the mesh is placed at the back of the render. Now that's not actually doing anything to strengthen the render at all. All it's doing is impeding the bond from the render to the wall itself. So it's very important that this mesh should be really situated in the central part of the render to offer its strength. And obviously in this detail, as you can see here, this picture, there is no mesh at all. It's completely non and void of any mesh. But in this picture where I've taken the core sample from, you'll see that there's cracking that runs all the way through the substrate and into the render as well. Now, I'm not saying for a minute that if it did have mesh in the render, then it would prevent that crack, because penultimately, if there's severe enough cracking in the substrate for any reason, by its shrinkage, movement, settlement, there might be a structural issue, the glass fibre mesh is not going to hold the render together, and that's a really important one to bear in mind. But it may have helped. Differential movement. So differential movement is if you've got a blockwork or brickwork, for example, you might have a brickwork structure and a blockwork windows that have been laid in, and you want to render over the top of it. So what's the issue? So the issue is that they're two different densities. Okay, brickwork being a high density material, and a blockwork being a lower density material. So they will move differently to one another. It's called differential movement. So, for example, in this elevation here, you see that they've got two different blocks. Now, this will be a problem. You're likely to see cracking from the different block types. So what do? Not a lot you can do. You know, if you've laid it like that and you render it over with a proprietary base coat, for example, and fully mesh it, you can even additionally put mesh over those areas where the two blocks meet. It still may not prevent the cracking from occurring. So, if for example this is quite a severe instance, but if there was a line that was drawn there, you might be building an extension, for example, that is flush. If this was brickwork and that was blockwork, an expansion bead between the two would prevent any issues occurring whatsoever. Potentially you could use, in this instance, a board system by where you batten it all off and then board it. That would prevent the cracking. But if you're going to render direct, there's a good chance that it would crack. Talk about hydration cracking. Now, hydration can affect the render application and curing, and some factors include crazing caused by the render drying out too quickly due to the weather conditions. Now, crazing can happen if you apply a render onto a thermalite block without a proprietary base coat to control suction. It can also happen if the sun's directly shining on the render for too long, or if the wind, even drying winds can affect that. And what happens is once the render is applied to the wall, it immediately starts to release the water content in the render itself. So if it's released too fast under the hydration process, it will craze at the front face of the elevation. Now, it doesn't necessarily mean it's a detrimental effect to the render itself or the integrity of the render. It just means that it is more aesthetically unpleasing. And you'll only find that crazing cracks will occur once the render actually experiences inclement weather, because those very, very fine cracks, they're less than 1 millimeter in width, will trap water, and you get this crazing effect. In order to get over this, generally you can just paint it, but which you'll see in the next couple of slides, overhydration or underhydration of the render can also lead to debonding issues. Cracking, efflorescence or shadowing in the mortar joints can be caused by applying render over saturated blocks or mortar joints. Again, that would come under shrinkage. You can also apply the render too thinly. If it's not thick enough You will also, the water content will release from the render too quickly, and also if you're looking at like a very severe location, if you apply the render too thin, then inclement weather or weather from the sea, for example, will hit the face of that render, and it will draw the moisture backwards and it subsequently into the substrate. It causes ghosting issues. And under freeze-thaw conditions, which occur naturally every year, the trapped water within the substrate will crystallize and it can debond the render. Cracking due to insufficient bond. Brickwork is a low density substrate, and it's a high density substrate, and it's got a low suction rate. So the common density with brickwork is around 1900 to 2100 kilograms per meter cubed. This means that a pre-treatment would need to be applied prior to rendering. So the more dense something is, like for example concrete or brickwork, the less it's going to actually adhere or bond to the render itself. So a proprietary render, we've got one called Prep, which you can apply at 5 mil over these concrete or brickwork first, and let cure to actually create a key for the following render code. So this is what we would specify on a brickwork or concrete substrate. So contact the manufacturer for specifications relating to low suction substrates, of course. Cracking due to insufficient bond, high suction substrates. So hydration issues, render curing too quickly, which we discussed previously, resulting in a weak bond to the substrate. So though sometimes the hydration issues may only cause slight crazing on the surface, if it's overhydrated too fast, and it can physically create a problem with debonding also. As you can see in this photo, this is a thermalite block with a sand and cement render, and obviously the overhydration of the render is actually released from the substrate itself. It's very likely that they didn't use for example, an SBR or any proprietary suction control on that, and it's released the render itself. So the aircrete blocks, the density is roughly about 400 to 900 kilograms per meter cubed. This means that there's more pockets of air or voids in the material that will draw too much water from the render, so it's being drawn inside and also outside, which again affects the bond. That's wise. So incorrect specification of material use, that's one of the main problems when applying the render again to an insufficient depth. So this is a case study of Bellevue Cottages in Bristol, which I undertook for the NHBC. This is a metal lath system with a sand and cement render. So with the lath system, you'll see that it's battened off. There would be a building paper and this mesh lath. Now the issue with lath is, and on timber, is that timber frame is a hydroscopic material. For example, it will take on water and it will release water in different environments. So if you apply a render to the lath system which is high in cement content, which sand and cement is, and not flexible, doesn't have any polymers in it that allows for any flexibility, you will have cracking that occurs because the frame will move. And that's what you can see in this particular instance. You can see I've got cracking from the windows here and running all the way down here. So this has to be all removed in order for it to be rectified. And for this, we used our Pro Wall system. This is a through section detail, if you like, of the actual lath system. So you can see the building paper down here and here, and you get your metal lath here. And this is your sand and cement product. This is the original paint, which is, as you can see, is a lime green to what it was on the surface. Now, what they have done is, rather than remove the system and put a correct one on there, they've used another flexible render over the top of it with a glass fiber mesh embedded into that render to hope that that would actually cure it, but it hasn't. The cracking and the movement of the timber frame came through, onto the face of the flexible render as well. Okay, so specification with regards to timber frame, always best to contact the manufacturer and get some idea of what they can use on a timber frame. We recommend a board system. So cracking in timber frame. So as you can see here, this is a floor joist zone or rim beam. Now, at the rim beam area, you will require something called a slip joint. Now, a slip joint is put central to the rim beam area, and it actually helps with shrinkage or contraction that happens naturally at floor level in a timber frame, and I'll explain why in a minute. But as you can see with this slip joint detail, I'll come closer to the camera, there's movement in the bead itself. Okay, now as you can see in this one, this hasn't happened. This is a back-to-back stop bead, which shouldn't work in this case, and it hasn't. And the contraction has happened within the frame, and it's cracked penultimately. And this is another picture which shows it very well. And you can see all the floor levels here. You've got cracking. Now this is a timber frame board system, and they obviously didn't apply it to a specification, and that's the end result. So why does it move? So the rim board area, or the floor plate, usually has a makeup of timber, all stacked vertically. Now those timber have moisture content within them. Now as the more people live in the timber in the timber frame structure and warm the structure up itself, the moisture content in the capillaries of these cross-grain timbers actually releases, and you get something called cross-grain contraction that will pull down and shrink these timbers here. So this is why you need the slip joint detail on the outside of the system. That actually saves it. See, what happens with the battens is they sail over that area and they're not screwed into the rim beam, and the board system is screwed to the battens itself. So that prevents any cracking within a render system on a timber frame. It's very important. So they will go in at every floor zone. And as you can see here is some drawing details obviously of the slip joint system and where it's situated within the timber frame and on the system. Vertical expansion within the system, that is done with just a normal expansion bead. And the render actually is applied to the system itself is a very thin, high polymer modified base coat. Ours is called Light, and a silicate resin top coat called Cottages. Now the full system looks very much like that. So you've got your board system, yeah, and a glass fibre reinforcement mesh, primer and top coat. So all in all, it's a crack-free system, especially when you incorporate the slip joint detail. Cracking in and around the windows with a system, again, we would create an L-shaped detail over the window. We wouldn't have any horizontal joints there or vertical joints there. And that would prevent cracking from occurring in around the window area. As we say, it's a high concentration point for cracking. And again, this is an EWI system, and again, no an L shape and no vertical or horizontal cracks or joints. Hope that makes sense. So preventative measures, what can we do to prevent cracking from occurring? So pick an appropriate system with a full installation instructions or specification. That's the most important thing to remember when thinking about what render system to use on a particular project. Request a specification from the manufacturer, and if the manufacturer can't give you a specification, don't use them. There should also be a guarantee. Using correct base coat can make all the difference. Use an approved applicator. Now that's one of the main important things. Obviously, use an applicator that's been through a training course or knows how to use the products that you may specify on this on your particular project. And again, request a guarantee. All pre-batch manufactured products come with a guarantee, usually 10 years. It may vary from manufacturer to manufacturer. Ours is 10 years. And again, it must be applied by an approved contractor. Using the wrong system. So as you can see in this particular photo, this is again a rib lath system. So it's similar to what was on the NHBC case study, but it's slightly different. It actually is a ribbed lath system within it itself. And where those ribs are, you can see that there is horizontal cracking running right the way through it. You can see there's a bit of moss growing on there as well. As you can see, where the crack runs right the way along, it follows the scratch coat, if you like, in the rib lath system. Now, obviously, with the fact that there's movement in the timber frame, there's also probably a lot of thermal movement acting on this elevation. That was a south-facing side, so you get a lot of thermal movement actually within the metal itself. That's actually in there. So that's why the cracking has occurred on this particular project. So what did we do? We removed all the rib lath system, and it was actually about 7.5 tons of sand, cement render and rib lath system to be taken away from that particular timber frame project, which is an incredible amount of weight if you think about for an external facade. Our Pro Wall system is about 28 kilos per square metre, so it's a very lightweight system, very flexible. So this is what we did. We removed it, put our Pro Wall system on there, and as you can see, the end result looked very nice, very nice. So thank you for your time, and I appreciate you taking the time to run through the cracking webinar with me. And as I said, we can send this webinar to you, and I will answer any questions you have further. Also, if you would like to email me, I'll give you my email information, and we're happy to look at any projects that you may have, timber frame or masonry, and consult on the render side of things. Thank you very much.